What happens if you hit a speed bump at 200 kilometers per hour? Spoiler, the car dies, you might fly, your spine probably files a complaint. Like where this is going? Hit subscribe before the G-forces hit you. Disclaimer: this is a theoretical exploration. Do not attempt this unless you are a crash test dummy, a cartoon stick figure, or made of vibranium. In real life, obey speed limits, listen to your suspension, and keep all four wheels on the ground at all times, preferably. Ready? Helmet on? Seatbelt fastened? Let's calculate the survivability of a very bad idea. Okay, what happens if you hit a speed bump at 200 kilometers per hour, 124 miles per hour? It's the kind of question that keeps scientists awake at night, and internet commenters awake forever. Not because it's a good idea, but because it's technically a physics problem, and physics problems are much safer on paper than on asphalt. Let's be clear, speed bumps are not ramps. They weren't designed for launch. They were designed for one purpose: to make sure you don't ask this question in the first place. But humans are curious, also impatient, and occasionally holding a Red Bull behind the wheel. So someone, somewhere, will inevitably think, what's the worst that could happen? Well, your suspension gives up on life, your tires leave the ground, your internal organs file for early retirement, and you learn that airborne is not just for planes. But we're not here to scold you. We're here to do science. And science wants to know, how fast can you hit a speed bump and still walk away from it, preferably without limping? Let's set up the experiment. Before we start doing math and breaking virtual bones, let's set the scene. We're going to simulate a totally normal situation, except for the part where someone drives over a speed bump at 200 kilometers per hour. To do that, we need three basic ingredients: a bump, a car, and a person who thinks this is a good idea. First, the bump. This is not some tiny yellow plastic strip from a supermarket parking lot. No, we're using a classic Dutch plateau speed bump, about 8 centimeters high and 4 meters long. It's wide, flat on top, and designed to politely destroy your suspension if you ignore the speed limit. Then we have the car. Just an average family car. Let's say it weighs around 1,400 kilograms. It's not a sports car or a monster truck. It doesn't have racing, suspension, or any fancy gadgets. This car was made to bring kids to school, not to go airborne. And to make it worse, the shocks are a bit old, just like the driver's judgment. Speaking of which, the driver. They're a standard human being, 75 kilograms, wearing a seatbelt, and full of confidence. No helmet, no roll cage, just a brain full of curiosity and maybe a little too much caffeine. And finally, here's what we're not using in this scenario. No tanks, no armored vehicles, no Cybertrucks. Just a person, a car, and a bump. That's all we need to test the limits of human curiosity and spinal durability. All right, time for some math. Not boring ones, fun, terrifying, why did I think this was a good idea numbers. Let's imagine you're still in your regular car speeding toward that Dutch speed bump. Here's what might happen at different speeds. Under 40 kilometers per hour, 25 miles per hour, you bounce a bit. Maybe your coffee spills. The suspension groans, but nothing breaks. You survive, physically and emotionally. Around 60 kilometers per hour, 37 miles per hour, the bump hits back. Hard. Your tires lift slightly. Your neck stretches more than you'd like. Your chiropractor sends you a thank you card. When you hit a speed bump too fast, your body experiences all kinds of forces. Sudden stops, violent jerks, weird angles. That's exactly why crash test dummies exist, so we don't have to find out the hard way. These dummies are surprisingly smart and expensive. A full crash test dummy can cost over $1.2 million. They're packed with sensors that measure exactly how much force different parts of the body experience in a crash. How far your chest compresses, how fast your neck whips forward, how much your spine bends. Spoiler, too much if you hit a bump at 100 kilometers per hour. There are safety limits for everything. Your chest compression should stay under 60 millimeters. Neck torque, twisting force, needs to be low to avoid serious injury. Your brain? It prefers to stay inside your skull at all times. Now, speed bump crashes aren't quite like hitting a wall, but they can still cause serious injuries, especially to your neck and spine. And while crash test dummies can shrug it off and do it all again tomorrow, you only get one skeleton. Treat it nicely. So, what did we learn? You can hit a speed bump at 200 kilometers per hour. You can go airborne in a family car. You can test the limits of your spine, your suspension, and your ability to scream in slow motion. But should you? Absolutely not. Speed bumps aren't just bumps. They're tiny mountains of physics, quietly reminding you that momentum is real, gravity always wins, and your skeleton is not replaceable. You can try to beat the bump, but the bump always wins.